Hi, it's time for another math easy solution. Time to discuss further into parametric curves and now go over example 3 of the example series, and this time solve this example, which states what curve is represented by the following parametric equations. And we have x equals to sine 2t, y equals to cosine 2t, and where t is between 0 and 2 pi. So to solve this, well, just like in my example 2 video, what we'll do first is if we recall the trig identity, which again I've solved this in my earlier video, I'll put the link below. So if we recall the trig identity sine squared theta plus cosine squared theta equals to 1. So this is the famous Pythagorean identity. But now in our case, what we have is theta, we'll just write that as equaling to 2t. So basically we could replace this with anything we want if it's the same thing. So then for our case, what we end up getting is, put this over there, we get now a sine squared 2t plus cosine squared 2t equals to 1. So now if you look at over here, this is just y squared, and then for this side, sine squared 2t is just, well, x squared. So what we get is a x squared plus a y squared equals to 1, which, as I went over in my example 2 video, this is the exact same shape. This is just a unit circle, or a circle with a radius of 1. So yeah, this is pretty cool actually, the exact same thing as before. Yeah, and here I've written that as well. So also from example 2, here's a link to it. I'll get to that in a bit. The parametric equation is x equals to cosine t and y equals to, yes, sine t, I just had a typo there, gave the exact same curve, which is a unit circle. You can click here. So yeah, you can just scroll down from this video, check the notes to show you. Yeah, so here are the notes from that video, and as you can see from that example, is x equals to cosine t, y equals sine t, and this t is also from 0 to 2 pi. And I showed that basically using that identity is the exact same thing. We get a unit circle, except in this case what we did, we started off here, t equals to 0 is at this point and rotates around once. So that's how it looks like. But in our case, notice how the points are traced as we increase t from 0 to 2 pi. Yeah, so in our case we have at t equals to 0, what we get is, well, x is equal to, so x is sine, y is equal to is the cosine, so x equals to sine of, well, 0, this just equals to 0. Yeah, and then what we have here is that y is equal to cosine of 2t, which is, well, 0, and cosine of 0 is just 1. So what we have here is a point 0, 1, so that's our initial starting point. And then what we end up getting is, well, let's just increase by a quarter. So at t equals to pi over 4, what we have is x is equal to sine of, well, 2 times pi over 4, which is just same as pi over 2, so sine pi over 2, and then where this one, again, recall, this is equal to 1. And then for y is equal to cosine pi over 2. So it's going to be the same thing, cosine 2 times pi over 4. So this will be equal to cosine pi over 2, which equals to, in this case, 0. And then the point that we get is now 1, 0. So it's rotating. Notice how it's rotating. So if we were to graph this out, what we get is something that looks like this. So this is our x, this is our y. Yeah, so then our first starting point at t equals to 0, we have 0 and 1. So in other words, 0, 1 here, and this is at 0, 1, and then this point, we'll just write this as t equals to 0. And we have this 0, 1 for the x and y axis, but then at t equals to pi over 4, what we get is now at 1, 0. So in other words, we go all the way from there to here. This is at 1, 0. Yeah, and the value here is at t equals to pi over 4. So what we get is we're rotating across here like that. And notice that it's a unit circle, so that eventually we'll get to, well, a full circle going this way. So we're moving from there to here, and then we're going to rotate all the way around, something like this, eventually get to this point here. This one is at 0 and negative 1. And this one is actually at t equals to pi over 2. We just move a quarter. So moving a quarter goes across like this, and then rotating this about even further, getting to this point. Now this is roughly, yeah, this is at -1 and 0. So we're moving across this way. So then it goes like this, and then all the way around we get a circle. It's not drawn perfectly, but yeah, we get a circle, so we get around like this, and then eventually when it gets to there, first off, this value right here is another quarter. So we move 1/4 is pi/4, 2/4, this is going to be pi/2, and this one is just, well, t is equal to 3/4 pi, or 3/4 of pi, and then all the way up to here. But then by the time we get over here, this is simply just a value. So at the on this side we get t is equal to, well, pi. So we move the quarter. But notice that in our case it's 0. I mean, t goes from 0 to 2 pi. So after a full rotation, notice that, well, we still have another full rotation to go. So then we would do the exact same thing. So we would rotate it about twice, like that. So what we actually end up having to do is having to do 2 rotations, and then where we eventually get to this point right here, or this amount of curves, and then eventually get to this as well. This is going to be equal to 2, t is equal to 2 pi, like that. So notice how we rotate twice. So we start off from here and rotate twice around the circle to getting over to this point, like that. But then and then we also rotate clockwise. But the difference is, when you go in my earlier video, we actually started off from here and rotated once around and getting back to that point. So so they both trace different paths, even though the actual shape is the exact same. Yeah, and here I've written those notes down, which is quite remarkable. So in example 2, the curve is traced by starting at the point 1, 0 and rotating counterclockwise, so rotating this way around. And we also started from this point, as opposed to this one, 0, 1, around the circle 1. So that one we just rotated once. But in this example, the same curve is traced by starting at the point 0, 1 and rotating clockwise. In other words, rotating it like this way around the circle twice. So thus examples 2 and 3 show that different sets of parametric curves can represent the exact same curve. Thus we can distinguish between a curve, which is just a set of points, and a parametric curve in which the points are traced in a particular way. So yeah, different sets of parametric curves, even though they can graph the same shape, the path it takes can be different, which is quite remarkable. So anyways, that's all for today. Hopefully you learned from this. Quite interesting example on parametric curves and how you can graph the exact same shape in different ways, which is quite remarkable. Anyways, that's all for today. You can, like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another Math Easy solution.